Hello students, today we will discuss about the types of adsorption. Types of adsorption. An experimental study after adsorption of gas shows that there are two main types of adsorption. These are briefly explained below. First is physical and second is chemical adsorption. So first if we discuss about physical adsorption. Physical adsorption. Physical adsorption is also known as van der Waals adsorption or physiorption. When a gas is held adsorbed on the surface of a solid by the van der Waals force, which are also known as weak intermolecular, without resulting into the formation of any chemical bond between the adsorbent and adsorbent. It is called physical adsorption, or it is also known as van der Waals adsorption or physiorption. So we can say when a gas is held on the surface of solid. When a gas is held on the surface of a solid, is known as physical adsorption. Now the characteristics of physical adsorption. First is physical change. As explained above, it is simply a physical change as no chemical bond is formed. That's why it is called physical adsorption or physiorption. So we can say that in this type of adsorption, no any chemical changes takes place. That's why it is only a physical change. So it is known as physical. It is considered as a physical change. Second is non-specific in nature. Non-specific in nature. Non-specific nature means as van der Waals force are universal on every solid adsorbent, every gas is adsorbed, only the extent of adsorption may vary. In other words, the surface of the solid adsorbent does not have any preference for a particular gas. For this type of adsorption, that's why it is non-specific in nature. Third is nature of adsorbent. Nature of adsorbent. As already explained, easily liquidable gases that is having high critical temperature are absorbed more strongly because they have stronger van der Waals force. That's why we can say that they have stronger van der Waals force of attraction. That's why in high critical temperature are absorbed more strongly. Next, reversible nature. Adsorption is a reversible process represented as follows. We can write the equation gas plus solid. Gas solid साथ में कुछ amount है heat. So when gas or solid adsorption is takes place between gas and solid, then it makes gas and solid. Then again this gas and solid can be detached. That means gas solid again can be formed individual gas as individual solid. If the gas is adsorbent and solid is adsorbent. So if we apply Lishivali principle, then we increase the pressure or decrease the temperature. Equilibrium shifts forward, that is adsorption increases. On reversing the condition, the adsorption will decrease. So we can also apply Lesch-Cavalier principle. Next characteristics is, let us pick low enthalpy of adsorption. Low enthalpy of adsorption. Physical adsorption involves only van der Waals force of attraction and no chemical change. The process is exothermic, but the enthalpy of the adsorption is quite low. So we can say that adsorption during the adsorption low enthalpy takes place because there are no any chemical bond formation of chemical bonds takes place. Sixth is low activation energy, or we can say that no activation energy. As this type of adsorption involves no chemical reaction, so no activation energy or very low activation energy is required for the adsorption to occur. So in this case, low activation energy is required. Multimolecular layers of adsorption. Multimolecular layers of adsorption. As layers of a gas can be adsorbed one over the other by van der Waals force, multimolecular layers are formed under high pressure. And last is surface area of adsorbent. Surface area of adsorbent. When we increase the surface area, the adsorption is also increasing. So for more adsorption, we have to increase the surface area. Now the second types of adsorption is chemical adsorption. As its name indicates, that in this type of adsorption, chemical change takes. Chemical adsorption, or we can also say chemiosorption or Langmuir adsorption. When gas is held onto the surface of a solid by forces similar of those of a chemical bond, which may be covalent or ionic in nature, the type of adsorption is called chemical adsorption. This type of adsorption results into the formation of what is called a surface compound. So, the characteristics of chemiosorption is absorption. First is chemical change. It involves the formation of a chemical bond between the adsorbent and adsorbate. So, due to the formation of chemical bond, this type of change is known as chemical change. Second, highly specific in nature. Highly specific in nature. This type of adsorption is highly specific in nature. Why? Because it occurs only if there is a change of chemical bond formation between the adsorbent and adsorbate. For example, oxygen will be chemiosorbed only on those solid adsorbents, that is carbon or metal, with which it can form oxide or hydrogen, will be chemiosorbed on those solid adsorbents with which it can form halide. For example, transition metals. Third is nature of adsorbent. As explained above, the adsorbent should be such that it could form chemical bond with the adsorbent. Fourth, due to the formation of the chemical bond, it is irreversible in nature. as it involves the formation of a compound that efforts to free the absorbed gas will release the compound instead of the free gas. Oxygen adsorbed on tungsten on carbon is liberated as tungsten oxide or carbon monoxide or carbon dioxide, hence it is irreversible in nature. High activation energy. Because it involves chemical reactions, so at low temperature, because like other chemical reactions, it requires high energy activation. Hence, like most of the chemical changes, chemiosorption increases with increase of temperature. For this reason, again may be physically absorbed at low temperature but chemiosorbed at high temperature. For example, it happens in case of adsorption of hydrogen ions when chemiosorption takes place by raising the temperature. By supplying activation energy, the process is called activated adsorption. 6. High heat of adsorption. It is exothermic in nature and is accompanied with the evolution of large amount of heat. This is of the same magnitude as those involved in the chemical reaction. Now, next is surface area of the adsorbent. Surface area of the adsorbent. Like physical adsorption, chemiosorption also increases with increase in surface area of adsorbent. So it is all about the chemiosorption. Thank you.